All right, moving on to example 33. In this case, we'll be doing the same type of calculations that we did in example 32, except instead of just counting the number of ways something is going to happen, we're going to look for the probability that a given event is going to happen. In these cases, when we're finding probability, we will need both a numerator that details how many ways the specific event in question can happen, and we will need a denominator, which is going to detail the number of ways that any of those events could happen without the specifications. So let's look at the first one so that you can see what that means. 10 high school students are trying out for a trumpet quartet. 4 of those 10 are seniors. What is the probability at least 3 seniors are chosen? So again, at least 3 seniors is a minimum of 3 seniors, which means we're looking at 3 seniors or potentially 4 seniors that are chosen for the quartet. We need 4 people total. So if 3 seniors are chosen, that means we need 1 person that's not a senior. Okay, that'll be the numerator of our fraction. That's the specific situation we're talking about. The denominator is just, I need 4 people to be in a quartet. So the denominator would be, how many ways can I choose any of the 10 people trying out to be in my quartet? So from here, now we're going to set up the combination part of this. Again, the order in which they're selected to the quartet doesn't make any difference. They're selected, okay? So 3 of them are seniors that we're going to choose. There are 4 auditioning. So out of those 4 auditioning, we would choose 3 of them to be in the quartet, and there would be 6 students that are not seniors. We would choose 1 of them to be in the quartet, or out of those 4 seniors, we would choose every one of them to be in the quartet. The denominator is, out of all 10 students trying out, I need 4 to be in the quartet. That turns out to be 25 over 210. Again, no need to reduce that fraction unless you really, really want to. All right, so moving on to a similar question. So Tim and Tom are twins trying out for pitcher on a baseball team. They need 5 pitchers on the roster, and there's 9 people trying out to be the pitcher. What is the, again, probability that the pitching roster includes at least 1 of the twins? So again, we've got that at least a minimum of 1 of the twins. So what would that look like? That would mean you would have 1 of the twins, or potentially you would have both twins on the pitching roster. We can't have more than 2 twins on the pitching roster because there's only 2 to begin with, but we do need 5 pitchers total on the roster. So if 1 twin makes it as a pitcher, that means that we need 4 players that are not twins. And if both of the twins make it, then we would need an additional 3 people that are not twins to be on the roster. That will be over the total number of ways to get any 5 people to serve as a pitcher on the team. So when it comes to the twins, there are two boys trying out that are twins. We would choose 1 to be on the team. And since there are 9 people trying out and 2 of them are twins, 7 of them would not be, we would need 4 people to be chosen to be a pitcher on the team. Or plus, we want both twins to make the team. So there's 2 of them. We would choose both of them. And of those other 7 players trying out, we would choose 3 of them to round out our group of 5 pitchers. Our denominator is, out of all 9 kids, we just need any 5 to be a pitcher. That would give us the total number of ways we can pick any 5 people to be a pitcher. So again, adding and multiplying in the numerator, we'll get a total of 105. In the denominator, we get 126. And again, if you want to round, that is up to you. All right, what I'd like to do in part C is I'm going to go ahead and set it up in words, and then I'm going to have you pause the video. I want you to work out the rest of the problem, and then I want you to do D and E on your own. And then when you come back, you can compare to what we've had done, and then any questions you have on those questions, please post them to the forum under the probability folder in My Open Math. Okay, so with our M&Ms, we have 6 green, 9 red, and 4 white M&Ms in a fun size pack. We're going to put 3 in your hand. What's the probability you get at most So a maximum 1 red M&M. So that would mean we get no red or we get 1 red M&M. In addition to the reds, it doesn't say whether they're white or green. We would just need 3 M&Ms that are not red. And if we get a red, that would also mean we have 2 M&Ms in our hands that are not red. And the denominator is how many ways we can get any 3 M&Ms to come out of the bag. So again, pause the video, work through this one with the combinations, do D and E as well, and then restart the video and see how you did. Okay, welcome back. So take a minute to see how you did, make some comparisons, both to the in words and the written out in combination form. Add any questions that you have about those, where those numbers came from, or how the words part came from. Please post those to the forum under probability in My Open Math.